Hello students and friends. In this video, let us discuss hybridization of some organic compounds. Okay. So here you can see the hybridization of some atoms. Okay. So here this one, that NH2. So generally this nitrogen has 3 sigma bonds and 1 lone pair. So it is sp3 hybridization. Now coming to this one, it also appears like this compound, but on this nitrogen, of course, same number of sigma bonds and lone pairs. Okay, this one contains 1 lone pair and this one contains 1 lone pair, but its hybridization is sp2. Okay, and now how this hybridization is different from this NH2 group. Okay, let us discuss in this video about the hybridization of some organic compounds. Okay, see this one. So here in this case, first of all, some basic examples. These are around this carbon are the sigma bond, so it is sp3 hybridization. This one also sp3 hybridization. This one is sp2 hybridization because this carbon is has 3 sigma bonds and 1 pi bond. Now here, coming to this oxygen also generally sp2 hybridization. Generally, we are not discussing the hybridization of this oxygen atom, but this one also sp2 hybridized atom. Okay, because 2 lone pairs and this one 1 sigma bond. That means here these 2 lone pairs are present in sp2 hybrid orbital. Okay, like this. So this oxygen also undergoes hybridization sp2. Okay, now this one is the sp3 and this is sp carbon and this one also sp nitrogen. Okay, it's also sp nitrogen. And next year, coming to this one, this is just in 2020 KVPY question. This one, this carbon sp3 hybridization and this nitrogen sp2 hybridization, because this one sigma bond, here 1 sigma bond, 1 lone pair, sp2 hybridization. I think everyone you know this one. Actually here steric number and the steric number equals to that means here number of sigma bonds. Okay, number of sigma bonds plus number of lone pairs and central atom. If this number equals to 2, that is sp hybridization. If this number equals to 3, that is sp2 hybridization. If this number equals to 4, that is sp3 hybridization. Okay. So now here coming to this one, this carbon contains 2 sigma bonds and 2 pi bonds. There is no lone pair, so it undergoes sp hybridization. And coming to this oxygen also inward in hybridization, that is sp2 hybridization, 2 lone pairs and 1 sigma. Okay, that's it. So here that methyl isocyanate, okay, methyl isocyanate MIC, this one has a 2 sp2 hybridized atoms. Okay, 2 sp2 hybridized atoms. Okay, that's it. And next one, this one again sp3 hybridization. sp3 hybridization. Why? Because it is sp3 hybridization. In this case, this nitrogen has 1 lone pair and 3 sigma bonds, so sp3. Okay. And now we are coming to this one. Again, this nitrogen has 3 sigma bonds and 1 lone pair. It must be sp3. But if it is a sp3, this lone pair of electrons are not inward. Generally, there is a one rule for the resonance. All orbitals, that means orbital electrons which are inward in a resonance, the orbitals must be in the same plane. Okay. If it is inward in sp3 hybridization, that means it is a non-planar compound. That becomes a non-planar compound. Here in this case, this lone pair of electrons are inward in a conjugation. That means here that these electrons are not non-bonding electrons. These are the pi electrons. Why? Because these are the pi electrons. Because these electrons forming a pi bond. That nitrogen and this hydrogen. This is the pi bond, and this one negative charge. Nitrogen carries a positive charge, and this is the pi bond. Now here you can see now around the nitrogen how many sigma bonds? 3 sigma bonds and lone pairs 0 lone pairs. So here hybridization is sp2 actually. These are not a non-bonding electrons. These are also bonding electrons. Those electrons form a pi bond. That's why we are saying that the number of pi electrons in pyrrole are 6. Okay, that's it. Next here, coming to this one, this nitrogen has a 1 lone pair and 3 sigma bonds, so must be sp3 hybridized. It is also, but its hybridization is sp2. Why? Because this lone pair of electrons are involved in a resonance with this benzene ring. As a result of this resonance, that structure converted to like this. That means here double bond nitrogen and CH2 plus, and this one negative charge, of course, remaining same. Okay, it means around the nitrogen how many sigma bonds? Just 3 sigma bonds. Number of lone pairs 0. That means here actually we should not say these are the lone pairs. These are the pi electrons actually, because these are also involved in bonding. Okay, so then hybridization is sp2 hybridization. That's it. Now coming to this pyridine. So in this case, 2 sigma bonds and 1 lone pair. So in this case, its hybridization is sp2. Actually, this lone pair is not involved in a hybridization. Here, this pi-pi conjugation is in pyridine. Okay, that means here that lone pair is present in sp2 hybrid orbital. For example, nitrogen. This is sp2 hybrid orbital. That is present actually in the plane. The carbon, and that means that lone pair is present in the carbon atoms plane. Okay, they are the pi bonds. So here these pi bonds are involved in a conjugation like benzene. Okay, this nitrogen also has one pi bond. Like benzene here conjugation possible. And this lone pair is out of the ring, and this lone pair is present in the molecular plane. Okay, that means it is not in the plane of these pi bonding orbitals. Okay, that's it. So sp2, and a number of pi electrons are the 6. Actually, this is not involved in bonding. Okay. Now here coming to this one. This oxygen is sp3 hybridization, 2 sigma bonds and 2 lone pairs. Now coming to this one. This oxygen has only 1 lone pair because these 2 electrons are involved in a pi bonding. Okay. And this one is a non-bonding electron. So here its structure becomes like this. So oxygen, pi bond, here negative charge, and here pi bond, this one carries a positive charge, and 1 lone pair. Now here how many sigma bonds here? 2 sigma bonds and not 1 lone pair. That means here sp2 hybridization. So this lone pair present in a sp2 hybrid orbital. Okay, so these are the pi bonding electrons, not non-bonding electrons. So because of this resonance, because of involving these electrons in resonance, its hybridization is different. Okay, that's it. Now coming to this phenol. In this phenol also same story. Here this one oxygen contains 2 lone pairs, but 1 lone pair. That means here 2 electrons are involved in a bonding. Okay, and this one oxygen also has a sp2 hybridization. In phenol, that oxygen is undergo sp2 hybridization. Now coming to this one, this is sp3, this is sp3, and this one also sp3. Generally, Carbanium we are saying sp3 hybridization. Okay, Carbanium we are saying that sp3 hybridization with the pyramidal structure. Now coming to this one, this carbanium, allyl carbanium, it is involved in a resonance. So here in this case, all carbons have same hybridization, that is sp2. With sp2, we are also sp2. Why? Because it is sp2, because that is converted into this one. Now this carbon becomes a sp2. So it is these 2 electrons are not non-bonding electrons. Those are also involved in a bonding because of the resonance, because of the conjugation. Now in this case, benzyl carbanium. So this benzyl carbanium also, this carbon hybridization is sp2. Now coming to this point, this methyl carbocation, it's a planar in shape. What is the hybridization of this carbon? sp2 hybridization. Okay, sp2 hybridization. The remaining one is a vacant p orbital. sp2 hybridization. Only 3 sigma bonds are there. Now coming to this one. This one contains 2 sigma bonds. Okay, the 2 sigma bonds and 1 pi bond. It means here it is a sp hybridization. sp hybridization. sp means here that is a linear actually. Okay, sp means linear. Now coming to this phenyl carbocation. What is the hybridization of this one? Actually, carbocation hybridization. if carbon has no pi bonds, that is a sp2. If carbon has a 1 pi bond, that is a sp hybridization. This vinyl cation, the carbon is a sp hybridization. Okay, of course this is a sp2 hybridization, 3 sigma bonds, 2 ch bonds and 1 cc bond, sp2 hybridization. In this case, this is a sp hybridized carbon atom. Okay, because 1 sigma bond, here 1 sigma bond, that's it. Okay, now sp linear here, but it is a very important point is this carbon is not sp, it is sp2 hybridization. Why? Because the sp hybridization means that must be linear, but if it undergo sp hybridization, here linearity is not possible because the 6-member ring linearity is not possible. That's why this carbon hybridization is not changed in sp2. That means in this case, like this, you can see, yes, this is the sp. Okay, it means like this. Here in this case, this positive charge, this vacant orbital is nothing but sp2 hybrid orbital. Okay, here vacant sp2 hybrid orbital is present, but in this case, sp means here this is sp means here remaining 2 p orbitals. One p orbital form a pi bond and one p orbital is a vacant. But in this case, it is sp2 hybridized, remaining 1 p orbital form a pi bond, and this one sp2 hybrid orbital is a vacant. Okay, why? Because this one only remains in sp2 hybridization. If it is converted to sp hybridization, it must be linear. Okay, but linear structure in 6-member ring is not possible. So generally man cheptam cyclohexane is not exist. Cyclohexane is not exist. Why? Because sp linearity is not possible in a 6-member ring. Okay, so in case of the raste, if you write the structure of this one, that must be like this. That must be like this. But this type of structure, this type of compound is not exist. Okay, so that's why your phenyl carbon, all carbons sp2. Okay, now coming to this one also sp2. Okay, here sigma bond, and this is the one orbital with electrons. That means it is also sp2. Okay, these 2 electrons are present in a sp2 hybrid orbital, phenyl carbanium. Okay, now next, in this case again the same story. Here expected sp3 hybridization, but this lone pair of electrons are involved in a resonance. That's why this one sp2 hybridization. Okay, these are not non-bonding electrons. Should not consider the non-bonding electrons in calculation of the steric number, because these are all involved in a pi bonding. Okay, now this one also lone pair of electrons are involved in a resonance, so its hybridization is sp2. We should not count this lone pair, just to consider it as 3 sigma bonds. Now for suppose if it is like this, no pi bonds, no conjugation, okay, then its hybridization is sp3. Okay, that's it. Now we are also generally expected sp3, but these 2 electrons are involved in a bonding. That's why its hybridization changes to sp2. Here also same story, sp2. Now coming to the anhydride. Okay, coming to the anhydride. First suppose CH3, CH2, oxygen, CH2, CH3. In this case, this oxygen, either oxygen has sp3 hybridization, but in this case, this lone pair of electrons are involved in a resonance with this C double bond O or with this C double bond O. That means these are not non-bonding electrons, these are the pi bonding electrons. So you have to count this sigma bond, and this non-bonding electrons. So its hybridization is sp2. Okay, that's it. So here in this case, next here also some examples. Okay, so do yourself and give a comment in comment box. You can give the answers in comment box. And this one also here, use the structure below and indicated numbers to answer the following. So here you can see again, this is sp2 carbon and this oxygen is a sp2 oxygen, because lone pair of electrons are involved in resonance, like that. Okay, so your answers put in comment box. Okay, thank you for watching. Please share the video and subscribe my channel.